Hi everyone, I'm Sneha and I'm working as an Assistant Development Executive at Alumni Relations. Today, I'm so delighted to welcome you all to the Alumni Master Classroom, Smart Electric Vehicles and its Energy Sources by Kislay Pankaj. So Kislay received his bachelor's degree in electrical engineering from IIT Gandhinagar in 2013. He's currently working as a Chief Technology Officer at Micelio Electric Vehicles, Bangalore. At Micelio Motors, he is designing a new EV for B2B last mile cargo carrying purposes and related IoT devices. The primary motive was to create an ecosystem that propels EV adoption. He was also the founding member of Ather Energy, India's first smart electric scooter. Kislay is also keen on bridging the gap between science and philosophy, through which he believes he can attain the purpose of life. He also believes in responsible innovation too. So I'm not taking much of your time, Kislay. Over to you.
Hey, thank you, Sneha. That's a very kind introduction. There seems to be some instability with my internet, so if I lose you guys in between, please bear with me. Good afternoon, everyone. It is really very, very exciting to come back and address. The happiness inside me is obviously visible to all of you. It's very exciting to come back and address your old alma mater after such a long time. I see that there are some familiar names that I should definitely address before starting my talk today. Good afternoon, Raghavan sir. You and I know that this journey that I'm on would not have been possible without the initiation that you provided so many years back. So welcome, and I'm so glad to be talking in front of all of you today. Hi. Good afternoon, sir. So I will just start my presentation. So let's make this an interactive session because I love to answer questions, etc. At any point in time, if you feel like there are things that you want to start and you want to confirm, please do pitch in between and don't hesitate. Let's make this an interactive session. So a very brief introduction about who am I and why am I speaking. I know Sneha has given a small introduction, but the story behind this is that just a bachelor. Yes, I've done slightly decent in my life, but what I've seen is that wherever I am today is a sum of choices. Predominantly, those choices were high-risk decisions in my life, including the whole, as some of you might be knowing, I was the second batch of IIT Gandhinagar. So at that point of time, this whole new IIT perspective was there, and it was a high-risk decision for all of us. But today, when I see that journey back again, it's like that was probably one of the best decisions of my life, where it gave me that opportunity to start things from scratch and learn how to do things. So new beginnings has been a part of my life. Back at IIT Gandhinagar, back at Ather Energy as the founding member, and now at Micelio as CTO and founding member of another company. There were definitely challenges, and last time I visited IIT Gandhinagar, there was an aura of innovation, there was an aura of entrepreneurship. So I just wanted to talk about it that many people, like having gone through this journey of making multi-million-dollar startups right now, many people would see the success of what a startup or a big company looks like, but not many people understand the hard work that goes behind it. So a couple of things that I feel I should talk about if anybody is thinking in this direction and would be thinking in this direction further in your life is that if you want to start any journey, there are three things that you have to look for. How big is the risk appetite? With high risk, do you want to be stable in a low risk, low gain kind of a perspective in your life? And that perspective can be in anything of life, not just career and anything. Or you are a high risk, high gain kind of a person. And the second thing is, do you thrive in ambiguity? Because when you are starting things up, there is lots of ambiguity, and you have to be okay with ambiguity. You can't see clarity everywhere. Life is not that clear. So you have to have an approach of finding clarity rather than obtaining the clarity and then thriving in that environment. So ambiguity and working with ambiguity is one of the biggest things that you have to learn if you are thinking of starting up. And the third ability is quick decisions. I read a book sometime back by Malcolm Gladwell called Blink. It's a book on how human beings are designed to make quick decisions and not deterministic decisions. Human beings are designed to make probabilistic decisions, gut-driven decisions, rather than very precise 0-1 kind of a decision making. So you have to choose whether you are okay with a very precise outcome, or you are okay with a decently precise outcome, but also the uncertainty of failure or success in that. That's the Heisenberg. Yeah, it's a manipulation of Heisenberg in uncertainty principle in your life. So now another thing I did want to talk about, it took me a lot of time to understand and why. See, I didn't want to make this conversation just about electric vehicles and technical, because when I go back to my alma mater, I understand what kinds of things that goes on in the life of a bachelor or a master's, or a person who is just finishing his who is on the verge of finishing his studies. So it takes time to understand what you want to do, and there is a Japanese philosophy called ikigai. Some of you might know it. In my case, it's just a culmination of 4 different things: what you love doing, what the world needs, and what you get paid for, and what you're good at. If all of these, many people talk about passion. So basically, if you see, passion is just a union of what you love doing and what you're good at. If that's falling into picture, then it's passion. And many people think that this is my passion, so I should be doing this. The chances of success in that is slightly lesser. You also have to see whether the world needs what you are passionate about, or whether the world will pay you for it. So that's the best way of determining what's your core area, what's your ikigai. And in my case, what I realized was what I love doing is a responsible innovation, and what I'm doing is building products, what I'm good at, and what the world needs right now is new age mobility, and what I can be paid for is smart electric vehicles, which we will be talking about later, late in the later few slides. So my ikigai for now, after a very long time of thinking, I've realized that my ikigai is intelligent mobility. Now, before we talk about any sorts of technology, it is important to understand that why innovation, why do people need to innovate? We have seen multiple different startups, companies, billion-dollar startups, who have an idea of converting one use case, which can be done in 3 mouse clicks or 3 button clicks, into a one button click business case. Do the world really need that? Do the world really need that kind of innovation? So the best way, in my head, what I have realized is that the best way to understand whether something is innovative or not, just doing new things is not innovative. I mean, the word innovation comes from there, but in the conventional sense, that's not how innovation was supposed to be done. So what I feel is that there has to be a word added on top of innovation, which is responsible innovation. And how you attain your responsible innovation? The first and foremost thing is you have to think whether whatever you are doing, whatever innovation you are doing, is it ethical or not? Is it right or wrong? Good thing is that in our IITs, we have humanities courses. We have courses like business ethics, business communication, sociology, philosophy, etc. And all of these courses will, later point in time, I realized that all of these courses, at that point of time, it felt futile. But now I realize that all of these courses helps you make a better person in and out, and also helps you make a more successful person. So that those kind of courses and understanding will give you an idea of what's ethical and what's not. The second thing is socially driven. If you are making any innovation for a niche part of the society, that's good. But you have to see how much masses can I cover in the society. And if you are really, if you are really yogic and your reach of mind is way beyond, even beyond human beings, then you have to think, can I do something for all the beings across the world? Right now, the entire world is talking about climate change. It's not just about human beings. It have its impact on human beings, but it's about everybody else as well, all kinds of beings. So you have to see whether my innovation is socially driven or not. And the third thing is that, is it sustainable? While I'm going to talk about electric vehicles right now, I do realize that 100 years, 200 years back, when the entire world started looking at energy as a source of doing things, we started with whale oil. I mean, back then we had wood, we had, power wood, etc., burning coal, wood, etc. But I'm talking fairly recent history, 200 years back. We started using whale oil. We started hunting whales. We started taking their fats and we started burning them. That's how the oil industry started. Then 50, 60 years down the line, 100 years down the line, people realize, oh, that's not sustainable. We can't kill all the whales. Let's switch to something else. Then people started digging earth to get the oil, digging the oceans to get the oil. And we know that, we got diesel, petrol, and all kinds of petrochemicals after that. And we know that it's still the world is dominated by that kind of energy sources. Now we are thinking, no, that's also not sustainable. We are digging earth, we are creating havoc in the climate, etc. Now let us switch to renewable sources. Sources which can be used either by solar or wind or water, etc., and which have significantly lower impact on the planet. But we also have to understand that where does this renewable sources come from? All the wind energy, the magnets that you put inside, the solar panel, the material that goes, rare earth metal that goes inside making the solar panels or electric vehicles, the lithium and all of the other rare earth metal that goes inside it. Where does it come from? So this whole cycle, we should not keep on repeating this cycle of switching from one energy source to another energy source and just simply calling it sustainable. We have to find what is the long-term perspective. We have till now only been shifting the problem rather than solving the problem of energy. So that's one thing. Good thing is that UN, United Nations, has set up 17 sustainability goals, and this has been set up decades back. And there are areas where the United Nations feels that the world should be moving forward in the direction of sustainability. And 17 areas are mentioned here. Most of the innovative areas, most of the human factors come into these 17 areas. But the sad part is that last time I checked this goals, the world has gone down and not up in the area of sustainability. That's a really bad sign that the world is going backwards rather than forwards in the area of sustainability. So we as young engineers, we within the gamut of whatever our social responsibilities are, individual responsibilities are, we should think about these things before we start the new next big $1 billion idea or the next big innovation in science and technology. So that's what responsible innovation is all about. Now, coming to the more tech part of the discussion is that, okay, so recently in 2020, there was a survey done by Lux Research, and it was found out that there are these 20 different areas which are going to be the next shining areas in terms of technology, in terms of industrial development. Good thing is that the area that I am in covers almost 5 of these, the green arrows, the shared mobility, solid state batteries, commercial vehicle automation, battery fast charging, and last mile delivery. All of these areas that I am personally working on. And these are one of the areas. And maybe some of you have would be working in quantum computing. I know that back then I also did some research on the side of quantum computing. And there are flow batteries, vertical farming, 3D printing. So as an engineering organization, you might have been working in quite a few of these different areas. But that's as I said, these are the areas that are in the rise right now. So if you are going to make certain developments in this area, then it will definitely fall back into what the world needs right now. Now, coming to the main agenda of the afternoon, why EVs? I have hired hundreds of people in the last couple of years of history of developing companies. During the course of the interview, I always ask them, why do you want to work in an electric vehicle company? Less than 1% of India's vehicles are electric right now. And most people say the future is electric. And while it is a right answer, but it is also a very cliche answer, and don't appreciate that. So what I am expecting is that have we gone into the next level of detail and really ask that question, why electric? And this goes back to a course that I took with Raghavan sir a couple of years probably a decade back. I'm not sure. Which in which I read a book by Iqbal Hussain, Electric Vehicles, and that's where I understood why electric vehicles are important. So the first and foremost factor is the IC. You can see the IC engine curve. This is the top speed curve of IC engines, and this is the top speed curve of general powertrain, general electric motors that you have. So if you see in the IC engine curve, you have to get slight amount of torque, you need to have certain RPM. In many different automotive sense, we call it idling, right? And that takes up power. And so basically, you don't get the torque that you require to move the vehicle from 0 to certain speed. But in electric motors, you have the torque available right at the start. So the need for a lot of other moving parts, especially transmission, etc., is not there. The gear shifting 1, 2, 3, 4, or whatever different gear shiftings that we have. So in general, the entire drivetrain is a much less complicated drivetrain in terms of if you use an electric motor rather than when you use an IC engine because of this top speed characteristic curve. And the second item is that the pollution angle, and this also relates to one of the factors of this curve, which was the idling part. So when you are switching, long back, Indian government introduced the time required on the signal, like if the signal is 180 seconds or 120 seconds. Why did they introduce that? Because after a decent survey, they realized that a lot of people are not switching their engines off when they are waiting at the traffic. And that when you combine millions of vehicles all across the world, or even in India, that huge amount of pollution that you create, not driving the vehicle, but just sitting idle. So there is no such problem in electric vehicles. Unless you are taking power from the electric engine or from the electric motor, you are not, unless you are moving, you're not taking any power from it. So there is no such thing as idling. There is no wastage there. And if you realize in the normal city commute, if I have to go from my place to office, in my 25 minutes of drive, it's almost 10 to 12 minutes I am sitting idle on traffic. I am not moving at all. So that's half of my runtime already saved if I don't switch on my engine at that point of time, which is possible, which is inherently possible in electric motor. The second angle is the pollution angle. Now, again, in few European countries where the entire energy generation has changed to more renewable resources, which does not generate that much smoke or polluting gases, it definitely makes sense to have electric vehicles because end to end you are eliminating the smoke. But in India, 80% of the electricity is still generated. Actually, slightly more than 80% is still generated using thermal, the coal as a primary source of energy. Well, then many people may ask that, okay, you are saving, by having an electric vehicle, you are charging it. So you're saving the energy or smoke emitted at the vehicle level, but you're still emitting smoke at the generation level. That is correct, 100% correct. That's the current scenario of the Indian scenario of the power generation. However, there are two aspects here. The Indian government is already working on shifting more and more thermal power stations to more renewable power stations using solar, wind, and water. The second aspect is when you are generating using an IC engine, when you are generating the smoke in a distributed manner where there are millions of vehicles in a city, to control that pollution, it becomes really difficult. And that is where Indian government has come up with BS standards, Bharat stage 3, 4, 5, and recently introduced the 6th standard. So those are filter standards which decides how much smoke gets emitted outside. And that's added parts, that's added cost, and that's added effort on every single vehicle. Rather, if you use an electric vehicle, and even if you generate electricity back at the coal power station, you can make use of, you can have filters back at the coal power station and in a centralized manner, which is way more easier to handle. So this is the second angle, which is the pollution angle. And the third angle is the smartness angle. So as we know, and we will talk about it in the intelligent mobility section, that mobility is becoming more and more smarter. We have automation happening in mobility, and that becomes way easier when all of your basic powertrain signals, etc., are electrical in nature. You don't need converters, you don't need sensors to convert the uh, different kinds of things into electrical signals to understand it. So that becomes simply very easy with electric when the entire uh, section is electric in nature. And the fourth, very important aspect which matters to the customer is, as I said, there are less moving parts inside an electric powertrain, and hence by default there will be lower maintenance because there are less moving parts inside the electric vehicles. These are the four reasons why most of the industry is shifting towards electric vehicles. Now, I have been an expert and I've been building two-wheelers predominantly. So just to give you an idea, this is not to make a business case, but just to give you an idea where the Indian scenario is headed. Right now, the scenario is that less than 1%, actually less than 0.5% of the total vehicles of India are electric in nature. So we are really, really lagging behind. But good thing is that, and these are very concrete projections from different business agencies, there will be 55 million two-wheelers in India, both IC engine as well as electric included, by 2025. Out of that 55 million electric vehicles, realistically, and these are realistic targets, realistically, approximately give or take 10% of those vehicles will be electric in nature. So 4.16 million two-wheelers will be electric in nature by 2025. And the lower circle is the high-speed segment. As you are aware that most of the electric vehicles in India are either unregulated or low-speed unregulated vehicles. But the trend is to shift towards high-speed, peak performance, no compromise kind of a vehicle. And the projections for that is 100,000 vehicles by 2025. Right now, we have barely 100,000 vehicles or so. So 100 or 200,000 vehicles or so. And in high-speed section, there will be actually less than 50,000 vehicles. So we have a long journey to cover. It's almost, in terms of business terms, it's a CAGR, cumulative annual growth rate of approximately 100% in almost different areas. So that's the market, that's the segment where the market is driving these requirements. Now, coming to how to build a successful EV company, having done 2 of these now, I understand that there are 5 different areas which gives you a great electric vehicle brand. First and foremost is the product attribute section. Now, for our section, because we are an engineering driven organization, technology driven organization, most of you would relate to the orange circle, which is the product attribute circle. But equally important is the other sectors. For example, service and charging infrastructure and the blue circle, the marketing side of the company. Back at Ather, we created a very good marketing brand. The distribution side, that automotive business does not happen without the dealership network, etc., that exists in our country. And then finally, the financial innovation part. Some of you who are interested in the financial side of things have to understand that there is a whole different, the entire industry is changing. The insurance, how the insurance works. People were buying vehicles, now they are shifting to leasing vehicles or aggregating vehicles. There are different kinds of business models that are coming up, and there's a whole lot of financial innovation that are needed for a great electric vehicle company to succeed. Most of the startups in India are just doing the orange circle. There are very few that have been able to tackle the all 5 circles. So that's what makes or breaks the difference of becoming just a startup to a successful company in the electric vehicle side. Now, coming to the sections of smart electric, the product attributes, there are, so as I said, for today's discussion, we are going to talk about the product attribute part because that's what relates us as an technology-driven organization. So what are the key 4 areas for electric vehicles? The first is powertrain, which is advanced and efficient powertrain. We are mostly importing most of the, apart from a handful of companies which I can count on my fingertips, most of the electric vehicle sales in India are happening via the kits that have been imported from China or some other country. and these are not efficient, and these are not very good technologies. Those are cost effective, but not really great. So there's an innovation needed on that side. Then there is obviously the old age automotive side, which is you need a great chassis because to hold everything together is the chassis is needed. The third is the energy storage, which is the battery side. We have heard a lot about lithium ion, etc. I'm going to talk about it later as well. Is that you need an efficient and safe energy source. Many people undermine the importance of safety in the entire battery pack space, but that's why it is important. And if we burn our hands there, the entire scope or the entire brand of electric vehicles in general will go down if we don't take care of the safety aspect. The fourth aspect is the intelligent mobility, which is, as I told, most of the things are being automated, AI driven, IoT devices are coming, edge computing is coming up, data is getting analyzed, and businesses are improving, individuals are improving their performance based on that data. So that's the intelligent mobility part. Now, I'm going to talk in detail about only two of these sections. One is the intelligent mobility and one is the energy source, because if I talk about details about everything, I'll need an entire day instead of an entire hour. So why do we need intelligent mobility? We all know that we are moving towards a connected world. We have already achieved connected human beings by having our mobile phones all the time, 24/7 with us. We are working, many of us are working towards connected homes, where we are having connected washing machines, connected fridge, etc., etc. The third thing is what we are, or I and the ecosystem of electric vehicles is trying to work on, which is connected transport. These are the three pillars of how human beings of the world works, which is a human being as an individual, human being while they are moving, and human beings when they are sitting at home. Now, so what are the building blocks? What exactly what I mean when I talk about intelligent mobility? So there are three areas, and these are bigger circles. Why? Because the scope becomes way bigger and bigger. The first and very simple scope is smart electric vehicles. Smart electric vehicles will be taken in detail later on. Then the other area is when you have a smart electric vehicle, you also need intelligent solutions around it, intelligent infrastructure around it, the analytics around it, which helps you to make your vehicle and your usage of the vehicle more efficient and more cost effective. The third part is the connected ecosystem, where everything else is connected to each other. We have a smartwatch, I have a smart vehicle, all of these things are connected together. So imagine a scenario where I have a connected drone, and I have an Apple phone with an ECG sensors on my wrist, and suddenly I have a heart attack. When I have a heart attack, the phone detects that I am having a heart attack, and immediately my smart vehicle or my smart drones comes and picks me up and takes me to a hospital. It's a pipe dream, yes, it's multiple years ahead, but it's gonna come. It's gonna come in my lifetime, in your lifetime, is what I'm saying, because a lot of people are working towards it. So that's the connected ecosystem that we are aiming at and we are progressing towards. In terms of smart EVs, there are predominantly three different perspectives. One is from a perspective of a rider who is actually riding the vehicle. The other is the perspective of a business. As I said, in my recent company, I've been working on, at Ather, I was working on commuter segment, which is the transportation for individual people like you and I, while we are going home or we're going to office or we're going to buy groceries, etc. The second segment is the whole business segment, where the Flipkarts, Amazon, the big baskets, Swiggies of the world, which gets delivery at your place. There's a whole different segment of vehicles that are coming up for that. And I'm trying to make my recent venture is about that. So that's the business part. And the third part is the connectivity part. From the perspective of connectivity, you have vehicle to cloud, vehicle to vehicle, vehicle to infrastructure, vehicle to anything, which is the whole connectedness that we were aiming at. So in terms of rider, we have ADAS levels. Many of you know what different ADAS levels are. Tesla has made a huge branding around it, that how their cars are autonomous in nature. But autonomous also has different levels. In very simplistic terms, level one is a driver assistant. For example, the whole speed limiter, or if you the cruise control, etc. Those kinds of things are driver assistance. Then there is ADAS level 2, which the feet is off. The throttle and the braking, etc., is being taken care by the systems. The third level is the steering is taken care by the systems, which is hand is off. The fourth level is when your eyes are off. You are still at the driver's seat, but your eyes are off because most of the driving is autonomous in nature. And the fifth level, the last level in this autonomous dream, is the mind is off. That is, you just sit in the vehicle, tell where you want to go, and it goes. That's it. You don't need to do anything in that. I mean, we have seen a lot of movies who have predicted that this is going to be the future, and I have to tell you that a lot of companies are sitting at either level 3 or level 4 of ADAS autonomous driving. But level 5 is very difficult to reach yet because realistic world conditions has to come into play, and our sensors, lidars, etc., are not yet in. The analytics, mostly the AI part, is not yet there. We have to collect a lot of data for that. So that's that. In terms of business, it's fairly obvious. Many people are interested to track the location. Many people want to know when their vehicle is going to fail. I'm not talking about when it has failed, it will give you a signal. I'm talking about when it is going to fail, the vehicle will be able to tell you that. And then there are different advanced technologies like digital twin, etc., which if people are interested, I can talk about it, but I'll choose to move on right now. And the fourth part, as I said, was the connectivity, which was vehicle to different kind, vehicle to X, vehicle to different kinds of things. Now, intelligent fluid solutions we talked about. So what do we talk about that? So these are the different areas: live tracking and visibility, productivity and efficiency, safety and compliance, real-time alerts, visualization and dashboard, charging and swapping infrastructure, and finally, smart accessories. I want to take some more time about it because as techies, a lot of us are really excited about the cloud part, on the app ecosystem part, or the IoT part behind the intelligent mobility or in general. So how all of these pieces comes together in the form of an ecosystem is you have smart onboard, which is your smart vehicle. You have smart infrastructure, which is your charging infrastructure, etc. You have intelligent dashboards. Like, for example, if you want to see how you did your ride today, how many kilometers did you do? Could you have done better? In an individual use case, these things seem futile, but in a business case, this is of huge importance that when there are thousands of vehicles that a business owns, whether the riders are taking care of that business, of the assets properly or not. Has it been stolen, etc. So that's intelligence dashboards. Then there are user applications. And then there are different API interfaces which helps you to do all of these things. So that's that. So yeah, all of these has to be connected together in form of a cloud platform. And there are companies. I don't know if you've heard about UPI. And obviously, you've heard about UPI. You've heard about Ather. So Nandan Nilekani's team has worked on that. So there is a team that we have been working on with, which is Nandan's team. And I have, so my present promoters are co-founders of Infosys. So on that front, we have been working on making this cloud platform, which connects all of these things together. And there is very less work done in this area. So if you have skills in these areas, please do reach out, or please do think about having startups or innovation or technologies built in these different areas. And as I said, the opportunities in all of these intelligent mobility sections is smart edge, which is the IoT part, the hardware part, the embedded systems part, and the embedded software part as well as part of the plan number 1. You need smart components, for example, motors, battery packs. All of these things are smart. It's not just about electrical and electromechanical anymore. It has to be smart. For example, one of the work that we were doing back then at Ather as well, was how do we see the vibration of a certain motor and realize by doing different kinds of Fourier transforms, how do we see that different kinds of failures are going to occur by analyzing different kinds of FFT distribution of the vibrations of motor. So using accelerometer. So this becomes a smart component. So most of the components in the electric vehicles are connected these days, at least in the good ones. Motors are connected to the controllers. Controllers are connected to the battery packs. Battery packs are connected to the telematics. All of these are smart components. We already talked about the strong cloud architecture. We did talk about the mobile applications. So we are going, currently I'm building a vehicle in which you don't need a key to start the vehicle. All you need is an OTP and that's it. So for that, you need a mobile application. This is just one application. There are multiple more. And there is an assortment of mobile applications that you need. And then there are portfolio of sensors and data filtering that is needed. I'll tell you a very small example. One of the use cases that I was trying to build some time back was I had to measure the sprung mass of the vehicle because I had to measure how much is being carried in the vehicle because in my digital twin project that was needed. So in the sprung mass of the vehicle, if I realized that if I put load sensors at anywhere in the vehicle, because the real rider is going to distribute his load in different ways, I'm not going to get a very good weight measurement of the entire sprung mass of the vehicle. So how do I really measure the sprung mass? And then by thinking lot more, I realized that, okay, maybe the suspension that is there, that is a purely mechanical component. The suspension that is there, the displacement of suspension can actually correlate to the sprung mass of the vehicle. So that's a very small example of how components are also becoming smarter and smarter in nature, or we need smart sensors that goes inside the component. Another very important example is right now in my car, I get alerts when my brake pads are going to fail. So when I have 500 to 1000 kilometers left on my brake pads, I get sensors on my car that I have to replace brake pads. And that is only possible because on the brake pad, there is actually a very small sensor, which has a very small V is equals to IR circuit, which decides that how much degradation has happened and sends a signal to the central control unit. And then the user sees it and takes action around it. So those are different kinds of smart sensors and data filtering that goes in a two-wheeler, in a four-wheeler, etc. The higher, the more premium you go in any vehicle, the BMW, the Audis, the Mercedes of the world have a lot of. My car has so many sensors that I never realized that. I feel that the complexity of electrical sensing inside my car is way more complicated than the complexity of vehicle dynamics or the dynamic elements that are there in the car. So that's the huge importance of data sensors and filtering. And finally, when you have all of these data, you need a strong mind and strong analytical engine to get the relevant inferences out of this data. So these are the six different sections where there is huge opportunity for academic world, for corporate world, for individuals to work on and to develop expertise. I'm going to move forward to the energy section part now, but if there are any doubts, I would love to take that up.
Hello, sir. Good afternoon.
Hi, good afternoon.
I wanted to ask, how do you deal with a lot of uncertainty in data like this? When I listen to your presentation, I feel okay, like I myself not able to understand a lot of things. A lot of things are uncertain to me. So how do I make things like how do I understand all these things?
Sorry, how do you understand what?
Like how do we calculate, take in account the uncertainty in data? Lot of things, a lot of factors are not taken into place. So how do we make out? Like how do we understand that?
Let me confirm. Is this a technical question or is this a philosophical life choices question that you are trying to understand?
So either ways, it's fine. Like I'm not able to grasp a lot of things.
Okay.
Sir, maybe what he is asking is, let's say, for example, you said that electric vehicles will be growing at 109% CAGR, right? But that is projected growth. You really don't know if it will grow at 109% CAGR, and what would change in like next 15 years? Because frankly, there are many uh, projections made, and those are like overly optimistic, and things like that. So how do you
Correct.
deal with that uncertainty? Like, this is one uncertainty that I can point out. Maybe he can point out more uncertainties.
Okay,
I
fair enough.
agree with
See,
this point. Like, as this is something I wanted to ask. Like, that a lot of things are just projections and predictions. So sometimes they are false as well. So how do we take?
fair enough. Fair enough. Okay, so interesting thing. As I said, the current scenario of electric vehicles is that there are 0.5% of vehicles on roads that are electric in nature, and we have seen that uh, many different agencies. I wouldn't go into the complexity of naming them, but many different agencies have committed and claimed that by 2030, 30% of India's vehicles will be electric. Now, according to the statistics that I was presenting, barely 10% of the vehicles would be electric in nature, because that's a very realistic projection. So see, whenever we start any project, or whenever we start any major decisions which needs huge amount of capital, huge amount of time and energy investment, we have to go out there and really understand, okay, so even in terms of research, there are different kinds of research we do. There is a secondary research, which is, type in the internet and go to Google and research, but that is just the starting point for what we do. We then go to the primary part of the research. In primary part, we have qualitative research, where we go talk to different people at length. It's a free flowing discussion. Then we take data from it, based on, okay, whatever he said about 10 different things. Two things are important. Let us have some statistics around those two things. So then we do a quantitative research around that where we take the same two different pinpointed 3-4 questions and ask 10,000 people for that particular thing, spread across demographics. So any product development or any major company starting has to be done only when you have a very realistic understanding of what is out there. Some people fail to do it, some people are good at doing it. That's the skill that you have to develop. That how do you seek this realistic estimate? Okay, the different agencies will claim this and that, but how much we have done till date? What is the project? What is the CAGR we have done till date? What are the different effects, factors that will affect it, and how much is it going to happen? For example, I'll tell you, majority of the electric vehicle development that has happened in the last 1 year has happened because of two reasons. So most of the projections have actually failed and added on top of it. People were expecting 40%, 50% CAGR, but now they are claiming 100%. It has the fuel has been added to the fire because of two reasons. One is the price of petrol going up, crossing the 100 mark, which has been a huge decision for everyone else. And the second is the government changing from BS4 to BS6. So that has made the cost of the Honda Activas or the two-wheelers of the world to get a jump of minimum 10 to 15 to 20,000 rupees. So now suddenly, when electric vehicles were no more viable in terms of the cost, etc., cost dynamics, now suddenly they have become super viable. And Indian Janta is such that nothing is more important than the cost. So the moment you make an economical offering to the Janta, which meets most of their needs, and it's economical in nature, that's where you get a business case out of it. So in short, that's what the answer is, that you have to go seek realistic feedback. You have to see what to rely on. There is so much articles and business articles, etc., about so many things, but people who go two steps ahead, for example, XYZ company will tell that, hey, we have launched the product and we are going to release 2 lakh vehicles in the next 2 years, or 2 million vehicles in the next 2 years. Now, everybody will read that news article and everybody will make a judgment on top of it. But if you are more invested in this decision, then you have to go find out, can I go trace a person in this XYZ of growing to that scale or not? So these are the next step activities that you have to do. I know these answers are very common sense driven, but that's what most of the business is, very common sense driven. And the second part is, like as you said, if you are seeking philosophical answer of how do you deal with uncertainty, it comes with a little bit of experience and a little bit of gut. As I said, you have to be gut driven. That okay, I'm going to take this decision and I'm going to move ahead with it, and I will think 10,000 times before taking a decision. But once I have taken the decision, I will just go ahead and I will take care of everything that comes in that path, right? My entire, I mean, maybe Raghavan sir will tell you more if he remembers. My entire life journey and the journey into electric vehicles have been very, very gut driven. And statistically, it was the most least likely suggestion that people would have given me. But I've taken that and I've somehow made that possible. And life is different that way. So, as I said, you have to make gut driven decisions and you have to take care of certain think before taking a decision, analyze, research before taking a decision. But once you have made it based on the gut, you have to go and live it. You have to live that decision. You have to take care of every challenges that comes in the path. So both technologically and philosophically, that's my answer to you.
Pankaj, I am Ramakrishnan from IIT Gandhinagar only. Can you hear me? Can you hear me?
Yes, hello. I can hear you.
I am Ramakrishnan from IIT Gandhinagar only, mechanical. I have got a doubt that do you think that the way our BTech programs and other programs are now going on, there will be a mismatch between the needs and skills developed? Question number one. Do we have to totally change that if we remove all mechanical, civil, electrical and start with some totally different new concepts of branches and courses and all? That is question number one. Question number two is that, you know, when we took the thing of power guzzling transport systems like airplanes, cars and buses, I can understand. In that case, where does the electric technology stand? Thank you. These are my
Hello. 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 Hello.
Yes, Kislay, we can hear you.
Okay, Ramakrishnan, sir, you were asking about power guzzling transportation. I lost you there.
That is because aircrafts, the magnitude of power required and hence the battery charging will be unbelievable compared to a four-wheeler or a truck even. Or even huge ships, you know, consumption of power is unbelievably high.
Correct. Okay, so even though I was not able to hear your question fully, but I will take a guess of what you're trying to ask is that how are current energy sources going to actually be applicable in huge power applications like bigger trucks, bigger ships, bigger those kind of, you know. Okay, so so first thing is in terms of courses, sir, if you ask me, my life has been very, very radical. It is not a conventional life. I know most of the 90% of the people who exit IITs go to non-technical jobs and they work in areas that have been very different from what they have studied. That's the common masses. But you have to ask me, my individual journey has been very different. In fact, the fact is that the importance of all the courses, whether it was power electronics, whether it was electrical machines, whether it was probability, importance of all of these courses, I understood after I went into the ecosystem of developing these things. But then, as I said, my journey is very unique. So I definitely see that the courses that I studied had huge relevance, including, as I said, humanities courses, including the philosophy and business ethics, etc., etc. These kind of courses, all of these courses had huge relevance in the lifestyle, in the choices that I've made in my life yet. However, there will be one small suggestion that I did also realize that most of the things, for example, I'll tell you a very simple thing that came to my mind right now is that the first time, so we have studied about capacitors from such a long time. From the first year of college, we have studied about capacitors. But we were mostly concerned about more or less 2 or 3 parameters of the capacitor. One was the capacitance, the other was the voltage. When I really started making products, power electronic products, then I realized there are 20 different parameters that I have never heard of. And I started understanding and researching and about these things, about how a capacitor can also act as an inductor, and what kinds of factors, frequency play on all of these in the working of a capacitor. So in the academic, we have touched these points very lightly, but we kind of skimmed over it and never realized the importance of what so different parameters could be about. The whole resonance circuits, etc. So what I'm trying to say is that there has to be an element of practical product or practical problem solving or practical product making in almost everything that we study. And good thing is that with the support that I got from Raghavan sir, I had that support, and we did some of the projects, and we did realize the importance of all of these things. But I feel the courses slightly more practical and project oriented rather than just very theoretical.
Okay, thank you. Thank you very much.
Okay. And the second part to your question was that, yes, I do understand that most of the high applications are not suitable yet, because the intensity of the power that we need is not there yet in terms of the most of the circuits. So for example, our electric vehicles started with lead acids right now, where you can see the specific energy is quite low. The lithium is sitting at a mediocre level. The fuel cell specific energy is quite high, but it has different problems, like specific power is very low. So there are different circles, and there are different applications of different things in these different applications. So for example, the drones, most of the drones today, where more energy is needed but not more power is needed, is being fueled by fuel cells. But where more power is needed in performance vehicles, etc., lithium ion, even a combination of circuit between lithium ion and supercapacitors are needed. So this is a good depiction of, in different applications, how you can use different kinds of energy sources and build your vehicles. I'm sure you know, sir, that many submarines are also run by huge battery banks. So there are examples of huge power applications being run through battery banks or energy storage solutions. But I think more and more advancement in graphene technology and fuel cells, etc., are going to push those high-end, high storage requirements, and we are going to take care of that section also. But we are not there yet. It's definitely true that we are not there yet.
Thank you, Pankaj.
Thank you. Yeah. I know I am short of time, so I will kind of skip some of the slides and just skim through it. So as I told, we will be talking about energy sources. So the primary sources of energy in a very layman language is, there are these 3 sections: lead acid, the metal hydride, nickel metal hydride, the lithium ion, the fuel cells, and the supercapacitors. Some are good in the power. Some can provide you more power, but can store very less energy. Some can store very high energy, but cannot provide you good power. So you have to basically choose as per your application of what you are trying to build, and hence what kind of sources do you need to choose. On that, now the customer factors that comes into play is, as we have been talking about, is safety is critical. The affordability is the next most critical element, and the reliability is most critical element. So customers are used to IC engine, which is a very reliable technology. So if you build something that is inconvenient or not reliable, people will just not accept it at all. And then there is ergonomics, which is the handling part. If anybody is started to make a battery, there are majorly 4 areas of what battery decision making is all about. The first and the most important is the cells. We will talk about a little bit about in that. Then there is BMS, battery management system, both hardware and software is the core crux of the battery, because cells, especially lithium-ion cells, is a ticking time bomb. If you don't control it well, if you don't keep it within limits, if you don't, it is like a, I mean, okay, there's another example that it's a very touchy, hearty, feely kind of component that don't go back and bite you. So how to treat it? It has multiple factors to it: safety, reliability, performance, modularity, and predictability. The area is the structural and the thermal element. So more this area for engineers. This is an area for embedded software engineers and people who have a very good knowledge on artificial intelligence and machine learning. This is an area for a mixture of chemical, etc. kind of engineers. And this is an area for mechanical engineers where structurals and thermals are studied and good products are designed in that. In terms of even if you have anybody has heard about different kinds of chemistries, as I said, the cells are important. So generally in any electric vehicle, 40% of the cost is the battery, 40 to 50% of the cost of the vehicle is the battery. And in the battery, 60% of the cost is the cell. So clearly you see the importance of cell. There are very few good suppliers of cell in the world, and there are very many chemistries that people are working out. Just in terms of different parameters that we analyze in terms of evaluating which cells, which chemistry is making sense, we have safe, cost, the specific energy, lifespan, power, and finally the biohazard part is there. And if you can see, there are graphite, NMC, NCM, and different. There are actually 20, 30 different chemistries. There are actually hundreds of chemistries. But these are the predominant chemistries that are there in the market right now. Right? Most of the market lithium-ion vehicles are NMC chemistry that is there, the NMC graphite chemistry, and some are NMC, LTO, etc. as well. I think most of us know what a battery is all about, but I'll still go with a small animation, which is there is an anode, there is a cathode, and based on the power consumption, there are ions which travels. The lithium ions travels from one side, the cathode side, to anode side, and then there is a catalyst and a barrier in between. So there are different kinds of importance to each of the single elements. Catalyst is lithium ions are unsafe because of the hydrocarbon catalyst that we use. The structural how many cathodes and anodes could be hold in the structural symmetry that is there. All of these, it's a very complicated science. I mean, it's if I start talking about cells, it will take another time. But to a very layman language, this is how a simple cell looks like. And there are different kinds of arrangements of cells. There are cylindrical, there is prismatic, there is pouch. These are cylindrical cells, if you see. These are the gaps. This is how you arrange these cells. These are prismatic cells, if you see. And then there is pouch cells. Most of the mobile phones, that's why I use the pouch cells. This is the pouch cell that you have. This is an inflated pouch cell, which has gone bad and probably is going to explode. That's pretty much it from my side, without going into too much technical detail about these areas, because these are very, very detailed areas. If there are any more questions, then I could take that.